Good day, class. Today's topic is on the RC time constant, and the acronym, the RC acronym means resistor capacitor time constant. So what we're going to be doing is we're going to be charging a capacitor using a power source that you can see here on my screen, hopefully. And we're going to let this run for just a second, and then we're going to discharge it. And when we run it, we'll hit this play button over here. Now, one thing to do, I'm not going to bore you with constructing this, but one thing that I can suggest to you is the pieces that you're going to build out, just place them in their respective positions. So example, if you want to put the ground somewhere, you place it here. You'll be grabbing a DC voltage, the power source, just grab it and place it in its appropriate spot. And then once you get it to its appropriate spot, let's just say I build another circuit out over here, you're going to connect it with these wires from the same area you got the ground from the schematic connectors. So we'll connect them using this junction piece. And when you um, are on an end of it, you hover over it and you'll see that little circle, might be a little dim there, and then you'll have your connection. So you're gonna want to bring out all your pieces first before you do anything. The other thing that you can do to each one of these components is click on it, and if you need to turn it 90 degrees at a time, you can uh, to get it to maybe match as in the directions. And so here we'll have um, our circuit built out. We have our switch closed. And what we're going to be doing here is we're going to quickly open it and see how this thing discharges. And what you want to look at is you want to look at it from the split perspective. And this is only going to run over a short period of time. So what you may get is you may get something that looks like a flat line. So you don't want to run it too long because what you have to do is you have to kind of find out where the area was of interest. So if you hover over this area here, you'll see that you have uh, a time displacement of you're about 1.7 seconds into this. And, and then over here, it's basically not a whole lot of information. I turned on I closed the switch again and got this thing to charge back up. So what you're most interested in is what's going on here where um, where it's discharging, right? So this looks like it takes place over um, just over a second. And again, you don't want this thing to run too long. You'll hit that play button to let it run. If you want to open and close the switch, you can. You'll So that's going to be a discharge of it, and you'll see a dip as I have, and that'll be you can kind of see that's the discharge when the switch is open, and then here's the charge. Okay, so I'm going to switch over to another screen here. So let's pause for a second. Okay, so let's look at the document that you're going to be working with. So there's a couple little corrections that I want to make here. We'll see it in just a second. But here again is essentially the circuit that we are going to build. We're going to open and close the switch. Right? So when we close the switch to the direction of A, we get a charge. The charge is going to be quantified by this equation. So our charge Q, we'll see it later on as little q. So it's basically, it is the same. Is going to be equal to the capacitance, and this is going to be in farads. So if you get something that's in microfarads, you're going to have to convert that. So microfarad is 10 to the minus 6. So you'll have to use that exponential notation, and then also multiplied by the voltage. Here we're going to have, you'll see voltage in terms of kilovolts. Actually, it was, in this case, it was just 5 volts, sorry. And the charge is going to come out in coulombs. So be careful when you use abbreviations. C is now taken up for our capacitance. So you want to probably write it out. So it's going to be so many coulombs when you submit that. So just be very, very careful. In physics, we run out of letters to abbreviate. So one thing that I noticed is that when you download this, some of the pieces don't come out quite right. So I'm in Notability app right now, and you can see how things kind of got jumbled up here a bit. And essentially what I want to take you down to is, let's highlight this, is this equation here. And I rewrote it, hopefully a little bit better, but this is E raised to the, this is all in an exponent, to the negative T over RC. And T, I'm sorry, and then RC is equal to R tau, right? That's Greek letter tau. And so eventually what we're going to do is we're going to have this equation that says our voltage at some particular time is going to equal to that initial voltage times that exponential E, that 2.718. That's a constant. You should find that on your calculator, minus T over tau. And so at this point, you should see that you have constants in all but 2 places. You'll have a constant. Let's highlight that. So this is a constant. This is a constant. This is a constant, right? And so you should be able to also graph this on your graphing calculator, or if you know what an exponential looks like, you can. So this is basically, this V naught is going to be that initial voltage, that voltage that you start off with, and it's going to discharge so that you get a graph that looks similar to, I'm going to skip all the way down here to this, right? So we start off with a maximum voltage of 5, and then it discharges. Okay, and so again, here's what the circuit looks like. This is where you have the in this area here. This is where you have the switch closed. You'll see a SPST. You don't need to know that. That just means a single pole, single throw switch. In most cases, you can think of this maybe as your maybe a toggle switch on your maybe a simple computer or some simple game. And when you'll see it in an open sense, looking like this. Okay, and we just set it up so that it was kind of like a two-way switch. So when this thing is closed, the charge runs through here in this manner. When it is open, this charge is going to want to discharge into what we call ground. And so if you're using this, if you're doing this in class, you want to be very careful. Make sure you're using your probes to determine, how much charge is left on that capacitor. In class, typically you use capacitors with not too much. They can't use whole lot of charge. But if you're out there and you're doing maintenance work or something where you have large capacitors, you want to make sure that you're grounded or that this capacitor is fully discharged before you even touch it. So they're like little mini batteries. They store a charge. So be very careful. Okay, so essentially here we're just gonna find tau. We're gonna calculate it. You can calculate it using our formula that we pointed out to you up here for tau. Keep in mind that, again, your resistance should be in ohms. So if you had to convert it, make sure you know how to convert it, not kilo ohms, but ohms. And your capacitance should be in farads. Okay, so let's just look at this one real quick so you can kind of get an idea of what's going on. In this scenario here, where you have some voltage, it basically says that you have 37% of your initial voltage. So at some point in time, you're going to get down to 37% of your initial voltage. And you'll see later on that we don't talk about it too much, but after 1 tau, something is going to happen. You'll get a certain percentage of it. And this goes for every capacity to the time constants in the discharge piece. So after 1 time constant, 1 tau, you're going to see a time constant of or percentage left of the capacitor of about 36.8%. So if the time constant, if you have 2 time constants, you'll have about 13.5%. 3 time constants, about 5%. 4 time constants, about 1.8% of the initial charge. 5 time constants, you'll have 0.7%. And after 6 time constants, it's virtually nothing left. So, and what I mean by a time constant, one more time, is I'm just going to make up a large time constant. So let's just say our time constant is 10 seconds. So this just means that after 10 seconds, we'll have 37% of the initial charge left. At this point, we have a 2 tau. So this is after 20 seconds, 3 tau, 30 seconds, so on and so forth. Okay. And our time constant is very small, so you should see your discharge happen very rapidly. Okay, so hopefully that helps you. If you have any questions, feel free to email me or give me a call. Take care.